So you're doing a cycle and you want to make your character move forward in space, but the feet keeps on sliding. How do you go from sliding to still? Hi, it's Airi. In this tutorial, we'll break down what's causing foot sliding and how to fix it.
Emotion.
On a cycle, whether it's a walk cycle or a run cycle, your foot is supposed to stay planted on the ground until the toe starts to lift up into your passing position. So when we go and look at something like this, how does foot sliding happen? What causes foot sliding? Here are the most common culprits. The first one is more than one axis is involved. The second common cause is that your move control or your ground control and the foot control do not cancel each other out. And the third most common reason is that the curves that are supposed to be doing the translation are not set to linear. All right, so time to unpack what all of those mean. When creating a simple progressive cycle, only one axis must be active when the foot is planted on the ground. So let's look at what's happening under the hood. In Maya, when you select your character, you'll see the three different axes. The Z axis is usually our forward translation, and this is what we use to move the character forward or backward, like this. Similarly, on the foot control, the Z axis is also the one that moves the character's foot forward and backward. Selecting my foot controller, this is what the curves look like. Now, on the frames where the foot is supposed to be planted on the ground, roughly from here, this is our contact position, the foot should be planted all the way up until the point where it starts to lift off. In this area, check out if there are any other curves that are active, so meaning they're not flat in the graph editor. We can see that there is something happening in here on our x-axis. So let's try to remove and omit this. Flatten out this curve. We are still seeing some sliding on the foot. So what else could possibly be causing it? If I look at this attribute, this one is our foot roll. It's not this one that's causing it because over here, they're still sliding that's already happening. So we're going to look at what other curves in here that are possibly affecting the foot sliding. If we look at our move all controller main control, there is another curve in here that is causing some movement, and that is the y-axis. So let's just remove this and see what happens. If I now move my character forward, we've eliminated all of the other curves aside from the z-axis that has movement in it. Now the foot is able to stay planted on the ground. Now that you've cleaned up your curves, is the foot still sliding? Let's look at point number 2, where our move control and our foot control do not cancel each other out. So on the frames in here, where the foot is supposed to be locked on the ground, this is what the curve looks like. So how do you make an active curve such as this one stationary or still? So the answer to this is you can cancel this curve out using a reverse curve. So what does that mean? This is an important concept to understand. When you want to stop the velocity of an object, you need to apply an equal amount of force going in the opposite direction, and that will bring its movement to zero. So, in other words, if the opposing curve is not of equal amount, the object will either continue to move in the same direction or it will start to drift backward. Here's an example of one object moving screen right. If the opposing object is not of equal amount, you'll see what happens. The current object is not going to come to a standstill. So the same goes with time as well. If the opposing curve is not the same length, guess what? That the object will still continue to slide. So what does this all mean, and how do we translate this into our characters, and how do we compute for the exact opposite of this curve? So you will need to find the distance between the first key and the second key. So you'll just grab this number right here, plug this in here. Now let's get the value of the second key, subtract that from the first one, and then grab this value. This number essentially is the distance that the character travels per frame. Once you have it, then you will plug this into your Move controller. Make sure that the beginning number is actually set to 0, so we actually have the correct distance from the first point to the second point right here. So on this second frame, we'll have to grab this one and then plug 0.407 into the value of the second key. Press enter, and let's check it out. No foot sliding. So to visually see what is going on in here, if I select the translate Z of both objects and I have a look at this, these two curves are the exact opposite of each other and they'll cancel each other out. This is the idea that you need to understand of two curves canceling each other out to keep something still. So awesome. So you did it. You didn't? Is it still sliding? There could be one more culprit, which is the third point. Some of the curves may not be in its linear form. If we select the controller in here and look again at the translate Z axis, you can see that this is not linear. So you can just select that, check that it is linear, have a look at what's going on in here. It's still sliding. What else could be causing it? Let's have a look at the translate Z of this controller. And that one has a little bit of an auto interpolation in there. So all you have to do is select this, turn that into linear, and then check out your foot again, and that should be back to staying still. So now your cycle, either it be a walk or a run cycle, should not have any more foot sliding. You can apply the same principles to a quadruped cycle as well. So I hope this info helped you. Hit like and subscribe for more 3D animation tips, and let me know what other animation problems you've encountered. This is Airi, and thanks for watching. So, this is still sliding. Did you perhaps scale the rig?